Hello, this video is for IXL Activity A1.F.2. The activity is titled Area. The 3-character code for this activity is Lima, Lima, Charlie. The question is, what is the area of this square? And by area, we're talking about what is the square units that are inside of this square. Well, it happens to be that the formula for the area of a square, and let's just say area of a square. Area of a square is equal to s squared, and where s equals the side length. So here we have a side length of 3. And indeed, you can see that if we separate this side into 3 equal parts, and also knowing that all squares have congruent sides, or all the sides, not all squares have congruent sides, but all sides of a square are congruent with each other, then we also know that this side up here is 3 as well. And if we separate it into 3 equal sections, then you can see that we end up with 9 square units inside of the square. And that's what we're talking about whenever we're talking about the concept of area. So if I go ahead and plug in this 3, the side length, into the area of a square, then I can see that 3 squared is what I would have. And so I know that the area of this square is equal to 9. So the area of the square is 9. On the next one, this here is a triangle. So let's talk about the area of a triangle. And actually, I want to go back a little bit. Area of a triangle, and we'll try to make sure we realize that's a triangle. Area of a triangle is length times width, where the length is the long side and usually the width is the short side. Now, if you want to switch it around and make the short side the length and the long side the width, that'll still work because we're multiplying them together, so it comes out to be the same thing. So let's do the area of this rectangle is equal to the length, which is 5.5. And we're going to multiply that times the width, which is 3. And I believe that's 116.5, if I recall. 5.5 times 3 is equal to, yes, indeed, the area of this rectangle is going to equal 16.5. 16.5 square feet. All right, so rectangle, length times width. Square, sides squared. Area of a triangle. Okay, area of a triangle. Well, let's go ahead and do the formula for that one first. The area of a triangle is equal to 1/2 times what we're going to call the base times what we're going to call the height. And the reason for this is I'm going to go ahead and draw a rectangle here. And whenever I draw this rectangle here, then I'm going to, after that, I can show you why the formula is what it is. So I have this rectangle here. Now I'm going to go ahead and go from diagonal to opposite diagonal over there. And what do you see? I have just created 2 separate, and if I did this exactly, they would be congruent triangles. So, and notice what would be the base. This would be the base here. This would be the height here. And if we were doing rectangles, this would be the length and this would be the width. Well, with a rectangle, we were doing length times width. Here we're going to do base times height, but we're also incorporating the concept of 1/2 because we only want 1/2 of the area because, well, it's a triangle, right? So any triangle you take, you could replicate it, spin it around, butt them up against each other, and they would make a, well, not necessarily a rectangle all the time, but they would at least make a parallelogram. So let's go ahead and move along. So the area of this triangle is equal to 1/2, and the base in this case is going to be 7. I'm getting that from right here, it's 7. And then times the height, which is this 3.6. Now I'm going to go ahead and calculate the area of this triangle. For 1/2 on the calculator, I'm going to put in 0.5. 1/2 is a decimal, is 0.5, times 7 times 3.6. And that's going to give me a product of 12.6. 12.6. So the area for this triangle is 12.6. Now on the next triangle, you'll see that the height is actually outside of the triangle. And the reason for that is that in a acute triangle, that is to say that all these angles here, right, all these angles here, that each of them are less than 90 degrees. So this is an acute triangle. And with all acute triangles, the height of the triangle ends up being inside the triangle. Now, with an obtuse triangle is an angle or a triangle that has one angle that is greater than 90 degrees. And you can see that angle's right here. This angle is greater than 90. And anytime with an obtuse triangle, the elevation, or that is to say the height of the triangle, ends up being on the outside of the triangle. So we're going to go ahead and use that formula. Area of a triangle equals 1/2 times the base times the height. And so area of the triangle, that looks like area, doesn't it? So the area of this triangle is equal to 1/2, and the base is going to be 7 again. And the height this time is going to be 8. And this one I can do without a calculator because area of a triangle, 1/2 of 8 is 4, and 7 times 4 is 28. So the area here is going to be 28. On the next one, on this triangle here, this is a right triangle. We see that because we see the right angle notation here. And notice that this is a little bit different. Unlike the acute triangle, where the elevation or the height was inside the triangle, or the acute triangle where it was outside the triangle, we see that with the right triangle, that the elevation is actually congruent with the side, and actually either side. If we turn the triangle this way, then it's congruent with this side. This would be our base, and this is going to be our height that is congruent with that side. Now, if we flip this thing over on its side to where this 9.3 side, we're going horizontally instead of vertically, then this here would become our height here. So you can see that either way with the right triangle, that the height actually shares that's congruent with the side lengths, either side that is connected to the right angle. Just for the fun of it, the side that is opposite a right angle on a triangle is called the hypotenuse. So the formula is going to be the same. Area of a triangle equals 1/2 times base times height. So the area of, it looks like a triangle there, the area of this triangle here is going to equal 1/2 times the base, 7.1, times the height, in this case 9.3. And I do think I'm going to use a calculator for the area of this triangle here. So again, the 1/2, I'm going to use 0.5 in the calculator, times 7.1 times 9.3. And the product of those three factors is going to be 33.015. So 33 and 15 1/1000ths. Moving along, we have here a parallelogram. With a parallelogram, this is going to be the area of a parallelogram is equal to the base times the height. So it's like a triangle, only it doesn't have the 1/2 part. All right. And the interesting thing about parallelogram is that the base times height, it's almost like length times width, right, for a rectangle. And if we were to stand this thing up, if we could kind of like just kind of push on this little corner here and push this thing back up to where all the angles were right angles, right, you could see how the area would increase. But if we push this thing down, as we pushed it down this way, and it got flatter and flatter, this height right here would get smaller and smaller. The value of the height would actually decrease, just like as we're squashing it down, the area inside would also decrease. So hopefully that kind of helps with a little bit of a visual there on that. But it is indeed the area of a parallelogram is equal to base times height. So the area of this parallelogram is going to equal, the base is 15.4. And we're going to multiply that times the height, which is 9.4. So the area of this parallelogram is going to equal 15.4 by 9.4. That produces a product of 144.76. Next one is a trapezoid. So trapezoid's kind of interesting. And before I explain it, let me go ahead and I'm going to draw a parallelogram. And hopefully I can get it kind of close. That looks right about there. Not too bad. So let's go ahead and angle that right about like that. That look good, you think? Okay. And let's just shave that off a little bit there. So if I had a parallelogram, right, and I would have my height right here, and this would be base times height, right? Would be the area of it would be equal to base times height. Now I'm going to do something here. I'm going to grab another line, and I'm going to do my very best to try to get this right about, if I go right here, and then I try to get it right about, I'm trying to eyeball this. It doesn't look, maybe about like that, kind of. It does look about the same, right about there. I think that looks pretty doggone close. So if I did that, then I would end up with two figures that look just like what we have here, which is a trapezoid. Okay, so this is a trapezoid here, and this side, I'm going to change my colors. This would be congruent with this, and this would be congruent with this, right? So we would end up with a base 1 and a base 2, right? And if the 1 hash was base 2, and then the 2 hash was base 1, then you could see that the full length of both sides would be base 1 plus base 2. But we need the concept, kind of like triangles, of the idea of 1/2, because we now have 2 of them, but we only want 1 of them. So what we're going to do is we're going to go ahead, and for the area of a trapezoid, it is 1/2 times the quantity of base 1 plus base 2 times the height. So hopefully you kind of see where the 1/2 comes from, because it's actually, you're taking one trapezoid, repeating it, flipping it around, turning it over, and turning it into a parallelogram to create the parallelogram. But again, you only want 1/2 of it, so that's why we're going to go with that. And notice that this is like base times height. If we thought about it, this would be like base times, that's what we, or better yet, base times height for a parallelogram. This is like base times height, but our base is actually base 1 plus base 2. But again, then we're going to use the concept of 1/2 to get rid of half of it. So that's where that formula comes from. So let's go ahead and do area of a trapezoid. And this is equal to 1/2 times the base, which is 6. Base 1, which is 6, plus the value of base 2, which is 4. And we're going to multiply it times the height, which is 3. Now let's go ahead and do the area of trapezoid is equal to, and I'm going to leave the 1/2 there for now. Let's do the 6 plus 4 to get 10. I think that'd be the easiest way to go and bring that 3 down. So we took care of the 6 plus 4. Now on the next step, let's go ahead and take 1/2 of 10, which is 5. Now let's bring down the 3, and now the area of trapezoid is 15 in this case. So our area equals 15. On the next one here, yay, fun, right? Fractions. So they're going to, you're going to have to be good at adding and subtracting fractions, multiplying fractions, etc., because these formulas involve multiplication, right? So I'm going to go with the area of, I'm just going to put T for trapezoid. It's a lot easier drawing that silly trapezoid, right? So area of a trapezoid is equal to 1/2 times the base 1 plus base 2 times the height. So the next thing we want to do is go ahead and put in our values. So area of a trapezoid equals 1/2 times, let's go with base 1. Base 1 is 4 2/3, but right here I'm going to go ahead and change this to an improper fraction. So 4 times 3 is 12, plus 2 is 14, and leave the denominator the same, so this is 14 over 3. So 14 over 3, plus, now the height right here, or I'm sorry, base 2, right? So 2 times 3 is 6, plus 2 is 8, so 8 over 3, so 8/3. 8 over 3. And then let's bring in the height, and let's go ahead and change the height to an improper fraction as well. 2 times 2 is 4, plus 1 is 5, and the denominator stays 2. So 5 over 2. Next, let's go ahead and do area of trapezoid equals, let's go ahead and do this 14 thirds plus 8 thirds. Well, if we do 14 thirds plus 8 thirds, well, they're like fractions, so that's great. 14 plus 18 is what, 22? It's 22 over 3. Right, I took that right there. Now this is all multiplication in between there, so times 1/2 times 5/2. And now we just have fractions all the way across. Now it looks like I could, do I want to simplify beforehand? No, I'm not going to do that. I don't want to get into another area here. We're just going to multiply straight across. So 22 times 1 times 5 is the same as 22 times 5, and that's going to give us 110 in the numerator. And then 3 times 2 times 2. Well, 2 times 2 is 4, and 4 times 3 is 12, so there's 12. Now, this is an improper fraction. I mean, this is the value of it, but we have to put it as a fraction, whole number, or mixed number. And whenever they say fraction, they mean a proper fraction. So in this case, we need to change this improper fraction to a mixed number. So let's do 110 over 12. How many times does 12 go into 110? Well, it goes in 9 times. 9 times. And what is 9 times 12? Well, that'd be 90, 108, is it? 90 plus 18 would be 108. Yep. So what's the difference of 108 and 110? That's a difference of 2. And denominator stays the same, 12. If I lost you on this, go back and do a little bit of practice between converting from improper fractions to mixed numbers and mixed numbers back to improper fractions. And you could put this in as 9 and 2 12s, but this would also simplify to 9 and what? They'll both divide by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. So it is 9 and 1/6 square miles. Here's another fraction one. Area of a triangle. Area of a triangle is equal to 1/2 times the base times the height. So let's go ahead and plug in our values. Area of a triangle is equal to 1/2 times, in this case, the base. Here's our base here. Let's change it to an improper fraction. 3 times 10 is 30, plus 9 is 39. And the denominator stays the same, so 39 over 10. And then our height over here. 8 times 3 is 24, plus 3 more is 27. So that's 27, and the denominator stays the same at 8. So 27 over 8. Now, the next thing we need to do is go ahead and just multiply all of this straight across. So area of this triangle is equal to 1 times 39 times 27. So 39 by 27 equals 1053. 1053. And 2 times 10, let me see, this shouldn't be too bad. 10 times 8 is 80. And then double that, that would be 160. Or 2 times 8 is 16, times 10 is 160. Either way. So now I need to change this improper fraction, 1053, divided by 160. How many times will 60 go into 160 go into 1053? So divide that by 160. And that's going to give us 6. And the answer is 6 point something or other. So let's take the 6 times the 160. 6 by 160. And that's going to equal 960. 960. So what's the difference between these two here? 1053 minus 960. So 1053. We're going to subtract the answer of 960, and that's going to give us 93. 93. So 93 over 160. 93 will divide by 3, but 160, 1 plus 6 is 7. That will not divide by 3. I know it's tempting because you think, oh, I can get there count by, like, can I get there but count by 30s? But actually, you can't get to 150 count by 30s, but I think that's it right there. So we're going to go ahead and go with 6 and 93 over 160. Seems like an unusual answer, but I did this activity. That's actually the answer. All right, next one here, they're going to take away the pictures from you, and you have to figure it out. It's about a square. So we know the area of a square is equal to s squared. So it has side lengths of 29. So the area of the square is going to equal 29 squared. And whenever we square 29, let's see what we get. 29 squared, that's going to give us 841. 841. All right, on the next one, parallelogram has a base of 32.7 meters and a height of 23.1 meters. Well, we know that the area of a parallelogram is equal to base times height, right? So let's do the area of this parallelogram. Plug in the base of 32.7. We're going to multiply that times this height here of 23.1. And whenever we do that, the area of this parallelogram is going to equal 32.7 times 23.1 is 755.37. 755.37. All right. Now they're going to take away a side length from you here, give you a height, and they're going to give you the area. So they're giving us the area, so we don't have to solve the area. So let's go back to that formula first. We know that the area of a triangle is equal to 1/2 times base times height. So let's go ahead and put in what they give us, and we'll solve for the rest. They give us that the area is 7.05. So I know it seems strange. You used to working everything on one side and getting an answer for the other side, but actually they're giving us the area. So let's put in 7.05 equals 1/2 as part of the formula. The base here is t. T is what we don't know. And we're multiplying all that times the height of 4.7. 4.7. So let's go ahead and do 1/2 of 4.7, right? 4.7 times 1/2, so 0.5 times 4.7 gives us 2.35. And don't forget the variable t that we're solving for. Now the t is tied to the 2.35 through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, and what we do to one side, we're going to do to the other side as well. So the 2.35 is going to cancel each other, leaving us just t on the right, and 7.05 divided by 2.35 is going to give us a result of 3. So t has a value of 3. So on ones like this that you get where they give you the area, just plug it into the formula, and then through algebra go ahead and solve for the missing length. A restaurant chef wants to install a new floor in her kitchen. The kitchen measures 7 meters wide, 11 meters long. The flooring costs $9.53 per square meter. How much will the chef's new floor cost? Well, we know how much it is per square meter, but we need to know how many square meters there are. Well, it is indeed wide by long, so this is a rectangle, right? So if you picture this in your mind, and a lot of times with word problems, a good thing to do is draw it out. And we know that it is 11 long and 7 wide, so that's going to be, what, 77, right? Multiply the length times the width. Now we need to multiply that 77 times the $9.53. So 77 by 9.53 gives us a total of $733.81. $733.81. Now this next one here is kind of tricky. You got to go back to perimeter as well. So if you did the perimeter activity, you know what perimeter is. A rectangle countertop has an area of 40 square feet and a perimeter of 28 feet. What are the dimensions of the counter? So they're giving you the square footage, they give you the area, right? And they also give you the perimeter. Well, let's go back to perimeter. This is going to be a rectangular countertop, most likely. So we know that perimeter is going to be equal to go back, hold on. Forgot a piece of it there. 2 times the quantity of A plus B, where A is one side and B is the other side, right? And we know that area is equal to length times width, or A times B, right? So we're looking for where we can plug in to something here. That is to say that we're going to plug in the values that they give us here. So perimeter is equal to, here the perimeter is 28. 28 equals 2 times A plus B. And over here we have an area of 40. So 40 is equal to A times B. Now we can get rid of this 2 over here by dividing by 2, right? What we do to one side, we do to the other. So we could do a little bit of work here and get this down to where the 2's cancel, and we're just left with A plus B. And 28 divided by 2 should be what, 14, right? So now we're looking for two numbers that equal 14 if you add them together. And if you multiply them together, you would get 40. So let's just start with, I don't know, let's do 7 and 7, right? 7 plus 7 equals 14. That checks out. Well, what about 7 times 7? That equals 49. Too much, right? So let's go with, let's increase it down to 6 and 8. 6 and 8 equals 14. What about 6 times 8? 6 times 8 equals 48. Still not there. So let's increase it the other way another time. Let's go to 5 and 9. 5 plus 9, that equals 14. 5 times 9 equals 45. We're getting down to 40. Let's try increase it down to 4 plus what, 10. 4 plus 10? I think we're there, folks. 4 plus 10 is 14, and 4 times 10 equals 40. So there it is. 4, 10, A is 4, B is 10, checks out both times, so the answer is 4 foot by 10 foot. It's just basically a guess and check, okay? So apply the perimeter formula and just kind of follow the same steps what I did right here to where you get down to A plus B equals some number, and then also see what A times B is supposed to equal for the area. And then final question, they get crazy, they get easier at the end. This is actually in the 90s. So here you just have to figure out which one has the greatest area. This is a parallelogram, so area is equal to the base times the height. And over here, this is a rectangle, so area is equal to length times width. So here we have area equals the base, which is 66, times the height, which is 72. And over here, for this one, area is the length of 82.7 times the width of 60.2. So let's go ahead and multiply those together and figure that out. So 66 by 72. The first one's going to give me an area of 4752. And the other one, 82.7 times 60.2. It's going to give me an area of 4978.54. The one on the right has the greatest area. All right, so that completes, even though it was lengthy, all of my examples for IXL Activity A1.F.2 titled Area, and good luck with your activity.